So Jesse Walt is a shareholder with over 15 years of experience. He's working currently at YJH Architecture. He has experience working with public and private entities spanning governmental, residential, technology, hospitality, and educational projects of all sizes. He has a passion for taking on complex problems, and his attention to details and innovative and creative thinking have made him adept at finding solution of any challenges. Thank you, Jesse, for joining us. We are very excited to hear about your projects and work.
Yeah, no problem. I'm happy to be here. Can you let me share my screen? Or can I share my screen? There we go.
Thanks.
Okay, so a little bit of background before we get started. In the time between when I was invited to present and now, YGH Architecture actually merged with Integris Architecture out of Spokane and Seattle in Washington State. And so I am now an associate principal for YGH and Integris Architecture, doing the same work, same complex problem solving, working for the same clients, all the rest of it. So what I've put together is 3 different projects that pre-merger YGH Architecture did, 2 of which are in Oregon and 1 of which is overseas, looking at the different ways in which we approach resilient design for each of these projects and clients, and so that we can talk about some of the similarities and the differences in how those work. So the first project is at the Portland International Airport. This project was a design build project with J.E. Dunn. It's a very complicated multi-phase project that is largely a parking garage structure, but also compromises a rental car and emergency operations building, which is right down here in this area. For this project, the emergency operations structure was a late add to the program. It actually increased the height of this building by 2 floors over what we were originally scoped to do. So that was challenging to bring in the sort of resilient design thinking late in the process. That scope add was added around DD, I believe, for this project. It's a challenging site also in that it sits just a few feet above the water level of the Columbia River in a high seismic zone in Portland. So we're concerned about a very large earthquake and silty soils that this sits on being saturated with water and basically sinking. So the strategy for this project to create a resilient structure was to put a bunch of large piles down to bedrock underground and create a series of grade beams with a mat slab structurally, and then build the building on top of it. So it is designed for a large-scale earthquake event. In such an event, Portland International Airport is designated as an emergency recovery facility federally, so it would be where Red Cross, National Guard, et cetera, would land everything and stage. So this is a very critical structure in that recovery planning, I guess. This project's also tied into the existing infrastructure. As we look through a section here, this is tied into an existing tunnel system under the airport that allows circulation from the parking garage to the airport. This building is sort of wedged in between. This small section here is wedged in between 2 existing buildings. It's about as tight as it could get. Just as an example of sort of the level of coordination that we were working with for this. And then here's a couple of examples or photos of the finished, some of the finished product. So the second project we're looking at is the Marine Studies Institute on the Oregon coast for Oregon State University. Here's the site. This is Coos Bay, so it's a bay that's open to the ocean along a river. You can see the ocean out here. It's an existing campus that is in a tsunami inundation zone, also in a high seismic area. The purpose of the campus is to study the ocean, and so it's very important for them to be located near the ocean. They have their own dock down here for their study vessels. So for this one, it was identified very early in the project that this was going to be a example project for how to successfully build a resilient facility on the coast in a tsunami zone that could provide a safe haven for evacuation of the campus. So there was a lot of political debate or public debate about whether or not that was the right approach. And we engaged in those conversations. There was a certain segment of the campus population that thought we should be building outside of the tsunami zone, that was a better resilient strategy to just not have to deal with it at all. But because the existing campus is down in the tsunami zone, it was important to provide a commitment both to that campus and to the safety of the people down there. So what we were concerned about here was a 9.0 earthquake and then the following tsunami that would come in. So we did extensive tsunami modeling that was very site specific. I'm gonna play a short video here showing the tsunami. Each one of these dots represents a boat, basically. So prior to the tsunami, the water moves out towards the ocean. And then you can see it pulling the boats out, and then eventually it's going to push everything back in. And so we were modeling the amount of debris impact we would potentially get at the building site during an event. This modeling was done in conjunction with some specialists at the University of Washington. So the important lesson from this is that it's incredibly site specific. If we had located the building elsewhere on the site, we would have had different potential impacts. And so really taking in that high, I guess, high level of site specificity paid big dividends for this project. So the strategies for this project were to look at different intuitive ways to evacuate after an earthquake out of the tsunami zone. We utilized special settings on the elevator to allow them to operate after a 9.0 earthquake to evacuate people up the building rather than the typical evacuation pattern of bringing people down to the ground level. We also put in the visual cue of an evacuation ramp that's visible from a lot of places on campus. So in addition to signage and emergency lighting that lead you here, it's also a great sort of orientation piece for the campus to know where to go should something be happening. And then there's also stairs as another way to evacuate up. And then this is the final product. So here's the evacuation ramp up the building into a safe haven, which has food stores and other things for an emergency event. the ultimate strategy, because of the large scale earthquake and then following tsunami, is that the ground floor materials are intended to be sacrificial in an event. There was no way to protect it from a large scale tsunami without basically barricading the site in large berms. So this is intended to wash out and then still be able to utilize the lab space and other spaces within the building relatively quickly after an event. The last project is the U.S. Embassy campus in Mozambique. This campus is located right across the street from the Indian Ocean. What's unique about this is that the Department of State has a stated goal of all of their embassy campus buildings having a 100-year life span. So early on in this project, we needed to account for things like anticipated global sea rise, climate change, other things like that. So a lot of strategies were developed early on to attempt to mitigate some of those concerns. And even this was originally done in 2013, and looking at what we were tracking for global sea rise at that point versus where we're at now, we were off by a bit. It's accelerated faster than we were expecting, unfortunately. So in this case, this building is also set on piers down to the bedrock, or all of the buildings on this campus are. We elevated the site 4 feet above the existing grade to mitigate localized flooding. When the site was purchased, it was basically the local collector for all of the uphill storm water coming down. We created a conveyance channel system around the campus to drain that storm water, basically along the periphery out into the ocean, and then elevated the space in between to account for global sea rise. Another consideration on this campus, because we do border the Indian Ocean, is that they have a strong cyclone season. And so that led to a lot of very durable material use and concerns about the fragility of materials and things breaking during cyclone events, which are very similar to hurricanes that we're familiar with here in the States. So in fact, early on in construction, the site was actually evacuated because a cyclone was making landfall right in the area while we were on a OAC meeting with the owner. So that was interesting. So one of the ways that we mitigated the noticeable added elevation to the site, because we did raise it 4 feet above the existing grade, which was at street level, was through this duned landscape, which helps sort of blur the fact that you're increasing elevation. Can really see this in some of these sections here with some of the security measures where this grade where the buildings are sitting is actually quite a bit above the street level, but we've blurred that line with the dunes, so it's not really perceivable. And then the finished product. So I realize I got through that fairly quickly. A lot of what we see when we're looking at resilient design is that the challenges are very specific to each site, and so are the solutions. And there's a lot of tools that we all have in our tool belts for coming up with these solutions. I mean, there's certainly tried and true structural methods. It's a little more inventive when we're looking at tsunamis. If we go back to this building, about twice the mass of this building is concrete underground to anchor it in place, which required quite a bit of structural design work. but this building wouldn't work if it was located on another site near the ocean. Similarly, the embassy in Maputo wouldn't work if it was on another site. It's very site-specific solutions.
Can I ask a question?
Yeah, absolutely.
What is the ratio of length for the understructure, the structure below grade, to the structure above? Is it like a cantilever length, or a lot shorter than that, or?
It's shorter than that based on the distance that they needed to go to get to solid bearing, as opposed to, so it's not a cantilever, it's roughly the height of the building. And
Okay.
it's about twice the mass.
Twice, I got you. Okay.
Thank you so much, Jesse, for the presentation. I feel like this is the first time I'm seeing like a design that's addressing a tsunami situation. Is that common? Is this one of the first projects?
This is the very first ones. We did a lot of research on this project. The very first ones we found were in Japan, addressing their tsunamis. There's a lot of vertical evacuation towers that exist in various places that are standalone structures. This is one of the first, if not, I think this is the second actual building structure to incorporate a vertical evacuation element that we're aware of. There's a school elsewhere in Washington, I believe, that incorporated something before we did, but it's one of the very first.
Interesting.
I have a question. So this seems to involve quite a wider array of skills than your typical architectural or even urban design professional. So what types of expertise did you need to bring in? Some of it seems extremely kind of land use and engineering oriented. I'm curious who the team included.
So we had dedicated tsunami experts in addition to our structural engineers. Any sort of tsunami resilient facility requires a peer review engineering also, as part of a newer code that's been adopted, and I'm forgetting the name of the code specifically. So we had that. We had civil engineering as well, which was that was the majority of the specialists that we brought in.
And the project on the Indian Ocean, similar?
The project on the Indian Ocean did not, was civil structural standard team. We brought in some specialists early on for the sort of the climate change modeling to account for sea rise and some of that.
Interesting, thanks. It just seems, sorry, I guess I am impressed by kind of the truly wide breadth of the site characteristics that were brought in. So much bigger than just the building itself.
Mm-hmm. Yeah, a lot of, well, because we work out of Portland and the cities are not as big or as dense over where we are. And so a portion of our work is on greenfield or brownfield sites that are not infill projects, whereas an urban designer would be more towards the infill. So I think that's part of the difference that you're seeing.
I also see that there are like, in all of these three projects, there is a lot of design related to like the site manipulation. So I wonder if, did you guys have like a specialist landscape architecture firm who helped you with that? Like,
so each of these actually used a different landscape firm for each three of these projects. We did have dedicated landscape firms on these projects. In the case of the embassy project, we have a landscape firm that we've worked with for years on different embassy projects that are very familiar with sort of differing conditions on the different sites the State Department may buy. In the case of this one, we worked with a landscape architect that's familiar with the coastal region here in Oregon. And for the one at the airport, we worked with a local Portland landscape architect, although the airport itself basically operates as its own small jurisdiction. And so they have very specific requirements around how you can manipulate the landscape there. So a lot of it is spending the time with the client to understand their needs and with the requirements that they have, and making sure that everybody understands them before we move forward with design solutions.
Thanks for the presentation. I had a question about, you had mentioned, I think on the State Department project, that the climate change projections had changed. And I think, like, stepping back into your initial comments about what resiliency is, like, how do you think about, or how should we be thinking about the unknown parts of these projections, and like how we think about the long-term effects of them?
It's a good question, and I was thinking about that as I put this presentation together. I mean, we do these with the best of intentions, with the information we have at the time. Both the good and the bad of it is that these resiliency assumptions, especially when it comes to emergency planning and things, hopefully are they never have to be proven.
Right, like worst case.
Right, it's all worst case scenario planning, and so hopefully you never get there. In the case of climate change and sea rise, it was more of we raised the site 4 feet in anticipation of I think 24 inches of sea rise is what our modeling indicated. It's been a few years since I've looked at that. It's not so much that the sea rise is anticipated to be worse from what I've seen, as we're anticipated to get to that end result faster than what was previously anticipated.
Yeah, that makes sense. It's almost like there's, and I don't have an answer either, but like some kind of flexibility that should be engineered in some way, that it could be amped up or reduced. I don't know if that makes any sense, but
I mean, we try to do these things with a safety factor,
right.
typical of any, good engineering practices. Structural engineers, I think, always put in a safety factor of 3. So that's certainly baked into the designs. But it also comes, I mean, the more robust you make it, the more the end product costs, and your client has to be on board to foot the bill for those things.
Yeah,
and understand the trade-offs that go into it too. So
exactly. I was thinking about, especially in sea level rise, when we're talking about cities like DC or other coastal cities at sea level, that like there are huge trade-offs in terms of the urban environment to raise things and what that street feels like now. And so when we're designing for these like worst case scenarios, it has experiential trade-offs, not just financial ones. And so it's like, how do we somehow factor that in, but allow it to change over time or ramp up as needed or something? I don't know. It's like, as opposed to just like all of a sudden raising everything a whole floor,
Yeah, I mean, I think both in the case of the embassy project and this marine studies building on the coast, we tried to take the resiliency measures and both mitigate them visually, but also where appropriate, celebrate them. There are things that they allow you to do that are design decisions you wouldn't necessarily otherwise make. So in this example, this first floor is sacrificial. So it's made from lighter looking and material. It's a more transparent floor. If you were to look at this building and guess what would happen if a tsunami came in, you would understand that this is going away. But this big solid block above it is sturdy and going to stay.
Yeah, that's
So it
fascinating.
starts to inform the design language in that way.
Great, thank you so much.
These are all really gorgeous projects with a lot of analysis going into them. I'm wondering, have they spawned other projects nearby to sort of follow suit?
Well, in the case of the embassy project, no, because it's the State Department project and we're working in a third world country. So while it spawned a lot of development nearby, they haven't really followed suit in terms of resilient projects. This particular project here that we're looking at on the coast has spawned other discussions and projects up and down the coast of Oregon that are in the planning stages right now. We're actually peer reviewing another evacuation structure in Washington as one of our current projects right now. And then the airport project has spurred some decision making in terms of operations at the airport, but because this project built out their emergency operations center, it doesn't really spur additional. There's not additional emergency infrastructure that would spawn as part of their resilient response. So yes and no.
The site in Mozambique, like Jesse, was that
I lost you mid-question.
Yeah. I think she'll be back. She must have some, yeah.
sorry, my headphones came up. My question is like, did they have, like, was there a reason why it's like an oceanfront site? I feel like if it was maybe inland, like a lot of the challenges on this project could have like been avoided, but was there
So potentially a lot of the inland is dedicated to housing in this particular city in Mozambique. So this is the capital city of Maputo. They have an existing downtown core over here, which is where the prior US embassy was within that. It was space constrained. And so they needed a larger site. And so the story behind this site is that there was a hotel that had been partially built on this site that was the size that the US government needed to develop their campus. And so it was a brownfield site that they were able to demolish the hotel and reuse. The hotel had actually been sitting abandoned since the Portuguese left. They were the colonizers of Mozambique. So when they left in the 70s, I believe, they abandoned the hotel and basically made it unusable by pouring concrete down the elevator shafts before they left. So it sat for 40 years, this site unused next to, there's a market just page south of the road here. There's an open air market, and then there's resorts and other sort of tourist infrastructure here along the coast. And so the US was able to demolish the hotel and develop this site, which was some goodwill with the country and the city. So.
And then one last question, has there been any event that has kind of tested the limits of these projects since being built? Because all three of them are already built. Have there been any natural events?
Fortunately, no. This area of Mozambique was largely missed in the last cyclone season. There were some bad cyclones further up the coast in Mozambique. They were able to, as a result of the emergency operations that have been put in as part of this embassy, they were able to facilitate US aid out of this location for the disasters up the coast. That's the closest we've come. Fortunately, there has not been an earthquake or tsunami on the Oregon coast in the last couple of years, or a major earthquake in Portland to necessitate the use of either of the other facilities. So if there had been, we probably wouldn't be having this discussion.
I think I have one last question, and it's about how in your firm do you guys approach the projects? Like, is it just because of the site specific reasons that you look through the lens of resiliency, or do you guys also apply this to other projects?
It's a good question. We try to apply this theory of taking a problem-seeking approach to all of our projects, and so we're looking for the issues and how to address them early. In the case of these 3 projects, those early identifiable issues led us to resilient solutions. And we do seek out projects which have resilient components, because we think we've proven that we can do this well as a firm at this point. I mean, all projects have their challenges. And so it's, you know, which challenges are you best at addressing? And I guess that's how we end up with these. We like complicated challenges. It's interesting.
One quick question. The materials that are sacrificial, what are they? Tsunami.
It's largely glass.
Just the glazing?
It's glazing, so it's a curtain wall system and a metal panel system with metal stud wall.
What kind of metal?
It's
Like aluminum?
Yeah, it's like an aluminum cladding.
Any of the dark facade would be sacrificial?
None of the dark facade is sacrificial. Even in a maximum event tsunami, it will not impact this dark facade.
And what is that? What is that material?
That's Shikoji bond.
Okay. Thank you.
Yeah.
Any more closing questions for Jesse? If not, I think we can conclude the